Okay, we're here with our student using the coordinate plane. And first we're going to talk about how to do distance to axes. Okay, so let's look at a picture. What axis is this right here?
The y-axis.
Good. And how about this one right here?
The x-axis.
Good. And then we have a point here, 7, 5. What does the 7 mean there?
It's the value of the x-axis.
Good. The x value of this point. And how about the 5?
The y value.
Good. And so now we're going to find the distance of this point to the x-axis and then the y-axis, like these dotted lines are showing. Okay, so first of all, what's the distance to the x-axis?
5.
5, that's right. Okay, now did you count that up or did you get it in a different way?
I counted it out, but I also got it in a different way.
And what was the different way?
The y value is the distance to the x-axis.
Good, that's great. And then the distance to the y-axis would then be the
x value,
which is 7, right?
Yeah.
Okay, good. Let's look at another point down here. -8, -6. What would be the distance to the x-axis?
Not negative, but it's just 6.
6, right? Okay. And then the distance to the y-axis?
8.
8, good. So here you kind of took out the negatives, right? Or else I guess another way to say that would be you took the absolute value of those values?
Yeah.
Yeah, okay. So good. So we can come up with a rule here. The distance of a point to the y-axis is the absolute value of the point's x-coordinate. So the distance to the y-axis, here it's 8, is the absolute value of the x-coordinate, which is -8. So that makes sense, right?
Yeah.
And we would do the same thing up here. And then the opposite is true too. The distance to the x-axis is the absolute value of the y-coordinate. So the absolute value of -6 is 6. Make sense?
Makes sense.
Okay, good. Now, that's the distance to the axes. What if we wanted to find something a little bit more complicated, the distance between points? So let's go ahead and take a look here. We've got a point 6, 8, and we've got a point -4, 8. So what would be one way to find the distance between those two?
Count.
Yeah, you could just go along, count the grid. But it might be easy to make an error, and that can also take some time. So what if instead we divide up this distance into two parts? The distance to the axis for the left point and the distance to the axis for the right point, which you can do really easily using the method over here, because you know that that distance to the y-axis is just the x value. So here it's 6, here it's 4. So what's the total distance between these points?
10.
10. So see how that makes sense? A lot easier than counting, huh?
Yeah.
Okay. And then let's see if we can find the distance between this point up here and this point down here using the same method. What would you do first?
You would count the distance between the 6, 8.
And what? The distance between the 6, 8 and what?
And the distance between the 6, 9.
6, -9?
Oh yeah, 6, -9.
And how would you do that? Kind of using the same method as up here.
Yeah.
How would you do that? Like, how would you divide up this whole distance?
Well, you would first do the 6, -9. You would count to the x-axis.
And how much would that be?
9.
9, because it's the absolute value of this -9, right?
Yeah.
Okay, and then how about this part up here?
Also count it to the x-axis, which is 8.
8. So then what's the total distance?
17.
Good, because you just add that 9 and the 8, right?
Yeah.
So that works. Okay, so that's a much easier way than actually counting all the way up. You just look at this y value here, absolute value of it, and this value here, and then you add them together. Make sense?
Yeah.
Okay, now let's go ahead and use this in the real world with a problem that looks like this. So first let me explain what this graph is. So I want you to pretend that you're a scientist and you're looking at values of temperature around the new year in a cold winter town. Okay?
Okay.
Okay. And here the x-axis is the days, okay? And New Year's Day is the 0 point right here. So these points over here are after New Year's Day. And what are these days over here?
Before New Year's Day.
Good. Okay, now, the y value represents the temperature, okay? And what color is this point right here?
Orange.
Orange. And what's the one down here?
Blue.
Blue. Okay. So the orange dot represents the high temperature for the day, and the blue dot represents the low temperature for the day.
Okay.
Does that make sense?
Yeah.
Okay. So now let's ask some questions, and I'll give you a hint. We're going to use our skills that we used over here about finding the distance between some points, okay?
Okay.
So we're going to go down here and we're going to ask some questions. First question. What was the New Year's Day temperature difference? Okay, and why don't you go ahead and explain how you would figure that out?
Well, you would take the yellow dot or the orange yellow dot and the blue dot, and you would on the y-axis.
So this dot right here?
Yeah.
And this one right down here?
Yeah.
And why are those the correct dots? That's right, but why are they the correct ones?
Because they're on the y-axis, and the y-axis is New Year's Day.
Where x equals 0, right?
Yeah.
Good. Okay, and then what would you do?
And then you'd count the distance between them.
Okay, good. And instead of counting like 1, 2, 3, can you use the method that we were doing over here to find that distance?
Yeah.
So what would that distance be, and how would you get it?
You could figure out what the point is, and then just count it down.
Okay. So what's the difference between this orange point and the x-axis?
I don't know.
From this point down to here. What are the coordinates of that point?
It's 5, 0, or 0, 5.
This one up here. It's a little bit above the 5, right?
Oh, 6.
So 0, 6. So what's the distance down to the x-axis?
6.
Good. And then how about this low temperature for the day? What's its distance up to the x-axis?
4.
4. Good. So then what's the difference in temperature, the total distance here?
10.
Very good. See that? So that's 10 degrees between those points. Make sense?
Yeah.
Okay, let's ask ourselves another question. What's the largest temperature difference? First, which day is it at?
3 days after New Year's Day.
Good. It's the one that has the high temperature way up here and the low temperature way down here, right?
Yeah.
And what are the coordinates of the high temperature?
Well, the y value is
Yeah.
9, and the x value is 3.
Good. And then down here, the x value is also
3,
and what's the y value?
9. Or, yeah, 9.
Well, what's the y value, though?
Oh, the y value is 3.
No, the x value is 3. You had it right.
Oh,
But the y value isn't 9. It's the opposite of 9.
-9.
Negative 9, right? Which means negative 9 degrees. Ooh, very chilly, right?
Yeah.
Okay. So this one is 9. This one's negative 9. What's that total distance then?
18.
Good. Very good. Okay. Now, let's do one more. See if you can get this one. I'm going to throw you a little bit of a curveball, okay?
Okay.
All right. What is the number of days between the 7-degree high temperatures? Okay. So, where would the 7-degree high temperatures be? Can you describe where they're at?
They're up on the positive side of.
Is this one
Yeah.
right here?
That's one.
And then directly over here is another one?
Yeah, it's
Okay. All right. And then how would you calculate the number of days between these two?
Well, you could count or use the method that we did before.
Okay. So let's use the method we did before. What would you do first?
Get the point of them.
Okay. So what's the coordinates of this point here? What's the x value first?
5.
5. And then what's the y value? We already know this because it's
8.
Actually, it's 7 because remember it's a 7-degree high.
Yeah,
It's a little hard to see because there's so many points going on. So the x value is 5, and then how about this one over here?
-3, or actually -7. Sorry.
-7. Good. Okay. Then what's the number of days then between them then? So this was 5 and this was -7.
12.
12. Very good. So you're getting really good at counting. This was 5 is the distance, and this was 7, and you add them up, and you get your answer down here is 12. So you can see how finding distance on the coordinate plane is actually a way that somebody like a scientist might find out really interesting things. Make sense?
Yeah.
Okay, good job.